Hello everybody, welcome back to another video. Today we're going to be doing a quite difficult problem in all honesty, but let's give it our best shot, okay? Let's get right into it. So we have the integral of dx. Now immediately calculus students might be thinking, what's the way we can approach this? Can we use some u substitution, trig substitution, or something more advanced even? Well, let's take a careful look at this. Well, in this integral, we have an integral symbol, and then we have d and x. What we can do is we can say that this is equal to d times the integral of x. But hey, we have no differential within our integral. So what we can do is we can write a dx, but that also means we have to divide by dx. So if we rewrite this integral, we have d, which is some number, like this, times the integral of x over dx, dx. But hey, dx is that infinitesimally small width in our graph. As we learn about integrals, that little small rectangle that we're minimizing, that's that width dx which we're talking about. So that means we can write this as a limit. This is equal to d times the integral of limit as dx goes to 0 of x over dx, dx, just like that, which is our differential. Now, if we look at this, x over dx, as dx goes to 0 from the left-hand side, we have limit as, let's say, dx goes to 0 from the left-hand side of x over dx. What's going to happen here? We don't know what x is quite yet, but we're just assuming some arbitrary value. Let's say that x is equal to 2 for this instance. Then that would mean that this limit becomes limit of 2 over dx as dx approaches 0 from the left-hand side. And this would equal negative infinity, because if you think about the graph, this is our graph of 1 over x. So it approaches negative infinity as you come from the left-hand side. And likewise, limit as dx approaches 0 plus of 2 over dx equals positive infinity. And since these are not equal, we cannot write this limit as anything. So hence, we can replace this limit with dne, because we don't even know what x is for positive or negative. So we can say this integral is equal to d times the integral of dne dx. Now, we could pull out all of our constants. We have d times the bigger D, capital D, of n. What is e? E is Euler's number, so we can write that as the limit as n approaches infinity of 1 plus 1 over n to the nth power of the integral of dx. And what is the integral of dx? Hey, we could do what we just did again. We said that this is equal to the integral of dx, so we can say the integral of dx is equal to d times d and the limit as n goes to infinity of 1 plus 1 over n to the nth power. All of this again. And we're going to have all of this copy and pasted once again to replace that dx on the right-hand side. Duplicate. We're going to have that. So we can essentially say that this is raised to the infinite power because this continues on forever and ever and ever. And then we're going to have an integral dx again. And yeah, ladies and gentlemen, if you have any questions or if I made any mistakes, please let me know. Happy April Fools.